Welcome to this tutorial video, intended to demonstrate the use of Orca3D version 3 design module to carry out a full basic intact stability assessment in accordance with IMO's Intact Stability Code 2008. Before we get into the workflow itself, let's briefly review the Orca3D product offering. Orca3D is organized into several modules: Design, Analysis, Advanced Stability, and Orca3D Marine CFD. The Advanced Stability module can generate a complete stability assessment, including compartment and tank volumes, tank tables, liquid load calculations, and free surface corrections. However, in this tutorial, we will focus on an earlier stage of the design process. We will assume that a hull form has already been developed and that preliminary weight estimates are available, but that compartmentation and the internal arrangement have not yet been defined. The objective is therefore to demonstrate how quickly and easily a preliminary intact stability assessment can be performed using only the design module. The starting point is Rhino surface geometry. Note that only the outer envelopes of floating components are required. Again, no internal compartmentation, which would come with a later workflow with module Advanced Stability. The first step is to create and edit fixed load cases within Orca3D. This allows you to define different conditions under which the vessel will be assessed. Several loading conditions can be computed at once. More about this a bit later. Perhaps at this point, let's spend a quick word on the VCG definition in the load case. As Orca3D basic stability does not account for free surface moments, the VCG you will input must be the one taking into account the virtual VCG rise due to free surface corrections, and this must come from your own weight and CG calculations. Again, Advanced Stability will, on the other hand, fully integrate the free surface effects. Next, we move on to defining downflooding points, which Orca3D refers to as points of interest. In this existing model, 2 points were already present, representing engine room ventilations as an example. Following this, as IMO's weather criterion includes a freeboard check, we go on and define deck edges using Orca3D's curves of interest. A useful aspect here is that existing Rhino geometry can be leveraged directly, making the process efficient and integrated. Here, the port side deck edge is conveniently mirrored from the starboard one. The next step involves defining the wind healing moment as per IMO's specifications. While you can manually enter the lateral projected area, it is more powerful to select existing Rhino geometries. In this case, all surface geometries above and below the waterline are selected. The rest of the wind healing moment settings can be adjusted. The IMO pressure is preset. You may then save your healing moment definition. Then, starting from Orca3D's side panel, pick a load case and right-click to select Run Stability Criteria Evaluation. Select the surfaces contributing to the ship's displacement, including both sides of the hull surface, transom, main deck profile with deck coamings, and rudder. In the next dialog, select the one or several load cases for evaluation. Then, choose the desired stability criteria from your Orca3D criteria library. Here, we select the IMO Intact criteria and include the weather criterion. Several useful options are available, such as exporting results to CSV files and selecting the direction of rollover. Direction can be default, port, starboard, or both. There are several reporting options that will allow to adjust the extent of the report, from concise to detailed. The IMO weather criterion requires the computation of a rollback angle. This is automatically done by the program, but you can override it with your own custom hull parameters if necessary. The actual rollover calculation can be monitored through a pop-up window. Note that viewports can be saved as JPEG images, and water planes can also be copied into the Rhino 3D space for further analysis. The extensive report includes the results of the criteria checks with clear pass-fail indicators. Reports can be exported in multiple formats like Excel or Word and are saved within the 3DM file for easy access when reopening the model later. Thanks for watching this tutorial on Orca 3D's Intact Stability Assessment.